So this is one of the question which they will ask in the exam. Explain the surge arrestor with a neat diagram. You are not supposed to write this diagram. So you are supposed to write the next diagram, this one. So this is a diagram which will be expected the left half side. Okay. Same diagram will be expected in the exam. You can refer my notes or the textbook also you can refer. That diagram will be sufficient. You can explain with respect to that diagram. So these are the diagrams which will show you related to the search arrestor, how it will be by looking into it, because whenever you visit any power station or any substation or any transmission station, we never easily identify the surge arrestor because it looks similar like your normal insulator. So if you look at the first figure, so it is almost like an insulator. We never come to identify whether it is a surge arrestor or it is a suspension type insulator or a disc insulator. So it will be a little bit of confusion. So initially it will be looking like this if you go with a cut view of that surge arrestor. So this is how the inside part will be connected here, where we will be having a end fittings will be connected, where the transmission line will be connected over there, and you can see that metal oxide the inside the layers of that within that surge arrestor, so that we can see in the next slide with the help of a diagram very clearly. So this is how it will be present within a surge arrestor. Okay. So basically this surge arrestor is nothing but a non-linear resistor. So it is a non-linear resistor. It is given here. It is a non-linear resistor. So which is in series with the spark gap. So in the previous diagram you can see there is a spark gap here. So where there is a gap at this part you can see that. So that is nothing but where we will be having a gap. So that is called as a spark gap. So here it is shown here. So which is connected in series with the spark gap, which act as a fast switches. So this spark gap acts as a fast switches, which can, whenever you increase the voltage, the gap will break down once the voltage has been increased. So that is acting as a switch, closing or opening of the switch. Very fast switches operation we can say. So hence typically a surge arrestor or a lightning arrestor will be in this fashion only, which consists of a nonlinear resistors and in series with the spark gap. So here just I will highlight with the because these names are not clear, so I will be writing with the number so that I can explain in detail. So number 1, it is a line end connector, where the line transmission line will be connected to that end. And number 2, so this is a porcelain housing. So where the entire outside part of the surge arrestor will be done with a porcelain. So it's within nothing but a insulator type. So where within that the entire part of your nonlinear resistor or sphere gap which will be present within the this house we can say. So the number 2 is nothing but porcelain housing, and 3 is your serial gap. So here you can see that the spark gap is written here. So these are the gap. It is not single gap. If you observe that in the diagram, there are a number of gaps here. So here is one gap, here is one gap, here is one. So hence we say it's a series of gap, similar like this. So we will be having a series of spark gap. And the 4th one is nonlinear resistor. So this one, which is shown here, this box which is shown here also. So this is a nonlinear resistor element block. So we say it's a block because more number of resistors will be connected over there. So hence it is called as a resistor block. And the 5th one is ground terminal. So where I can connect a grounding at this part. So this is a 5th one, ground connection. So because whatever the fault occur, the over voltage or over current is occurred, that has to be easily given or diverted to the ground. So then I need to have a proper ground connection. For that reason we have a ground connection here. And number 6, so here we have a springs which is not very clear. So when you refer the other notes or textbook, which you can see here, at this part we will be having a spring here. So where the spring will be, in the previous case you can see here, yeah, in this diagram you can see here spring you can see. Similarly, at the bottom side also will be having a spring. Okay. So we'll be having a spring at there, that is a 6. And number 7. So this part is my number 7, where it is a base of your arrestor, which will be mounted on any transmission tower. Okay, usually we connect this arrestor on the towers where the transmission line can be easily connected to that, so that we can ground to that. If any fault occur, it can be easily grounded also. It will never be hanging on somewhere else, like your suspension type insulator or disc insulator, which will be hanging with respect to the tower and the cable. So this is not in that way. It will be mounted on the transmission tower. Okay. And finally, 8th one, so which is here. 8th one, so this is called as a watertight sealing. So entire gap, whatever the things you'll be seeing, the register gap, everything, so this will be tightened with a water tight sealing. So we'll be having a water over there, so it will be tight completely, so that nothing, if any flash shower occur, it should not come out, so it should not damage anything else. For that reason, they make use of a watertight seal. So this is a diagram for a non-linear element surge arrestor. Okay, and in this we can write a voltage and current characteristics for this, because we want to know the characteristics of this arrestor, how actually it behaves. So we have a characteristics, so I will try to write in this only. So where with respect to volt ampere, voltage and current characteristics of a nonlinear resistor block. So this is with respect to nonlinear resistor block, where in the x-axis we have the current, which is given as ID. I'll explain what is meant by ID here. And in the y-axis we have a VD. So there are two graphs. One graph will be in this fashion, another is this way. So the first amplitude or peak of the first graph, this is a VD, this is VD, and the other graph at this point is called as a VR, and this is the point with respect to VR is IF, and the point where VD I am getting, that is a point is called as a ID. So this is a VI characteristics, and the surge arrestor operations will be done, that is also shown in terms of a graph only, how actually the operation will be done with respect to voltage in kV, y-axis in voltage in kV, and time in microsecond, time in microsecond. So here, so let me tell this one, your VD is nothing but your voltage across the diverter when discharging current ID. VD is nothing but a voltage across the diverter when discharging the current ID. So where ID is nothing but discharge current, ID is nothing but a discharge current, and IF is nothing but power frequency current at a system voltage VR. It is a power frequency current at a system voltage VR. So where VR is nothing but it is a spark voltage. Yeah, it's a spark voltage, and we have a few more things, that is VP and VS. VP and VS. VP is the protective level that we can see in the next graph. So I will plot that also. So this is with respect to VD, and this is VI. The amplitude is VI, and we have a current here. So let me take with other color. So this is ID, this is ID, and here we have a Vp, so this is Vp, and we have Vs, so this is Vs, this is Vs. This is a surge arrestor operation. So I will be explaining this. So here in the surge arrestor, where we will be having a nonlinear resistor element which is made up of a silicon carbide or a any other material which will be used, it will be like a stack type. So the resistor will be in the form of a stacks here. So you can see in this way, the resistor will be placed, a block of resistor, it will be in the form of a stack one over the other. So there will be usually one or two or three section, sorry, usually it will be two or three section of this block. So this is one block which will be kept in this way, two or three sections of resistor block will be present within that resistor block, nonlinear resistor block. So they are usually separated by the spark gap. Already we have seen in the previous diagram where we will be having a spark gaps, right? So we will be having a spark gap, it will be separated by the spark gap with individual blocks here. The entire assembly is housed in the porcelain watertight housing. So because of any damage is going to happen, I need to protect this entire part, it will be placed within the porcelain housing. So where watertight housing, we can say that. So in the VI characteristics, the resistance element where it is given by the ID, so that is nothing but your discharge current ID, which is given by the equation K into V to the power of A, K into V to the power of A. So here ID is nothing but discharge current, V is your applied voltage across that element. What voltage you are applying to that surge arrestor, that is a V, and K and A are the constant depending upon the materials and dimension of the element. So right now we are using a porcelain material here for a surge arrestor. Depend upon different material, your constant K and A will vary. Your constant K and A will vary depend upon the what type of material they are using for the surge arrestor. And in another figure, the surge voltage VI, which you can see over here in the black line, which is applied to the surge arrestor, that is the input voltage which is given to the surge arrestor. It breaks down giving the discharge current ID. So that blue line, whenever you apply the voltage, the discharge current ID will be break down within the surge arrestor and maintains a voltage VD across it, and maintain a voltage VD across it. This is the final voltage which will maintain, it is a VD. And this provides a protection for the operators to be protected above the protection level Vp. Vp is the protection level they have been taken. So that is a minimum value, we can say, the preset value. So it has to be that. So whatever the fault occur, that should be within that limit. So if you observe that now ID and Vs operating voltage are below this green line. So hence, so this will operate within the protection level. Hence we can say the surge arrestor is protecting the operators or any transmission line or any equipments within a power system. So this is regarding surge arrestor. Many times it has been asked in the exam with the help of a diagram explain the surge arrestor. Okay, if you write these three diagrams and if you explain regarding this, that will be sufficient. Okay, so this was the last part over here. I will wind up today, so I will continue in the next class. So where your module 1, so that may require hardly 2 hours, since all are short notes only. Very small topics are present within a liquid dielectric and the solid dielectric. So already gas dielectric we have seen already. So now liquid and solid is left out. So that part will cover in the